Hello lovely people, we are going to try and do a wiring video. Okay, I'm going to do my best to explain each and every JST connector, how it connects to the board and how it connects to its component. There have been a lot of questions on all of that because I know I'm not the greatest at documenting and my wiring diagrams. A lot of complaints have come in about, well, I'll do the best I can, guys. So here is the latest, I dare call it a wiring diagram. It's more of a JST wiring diagram or PCB wiring diagram. And done in my own style. Sorry guys, but just to give you a general overview, what I've done here is I've taken a section of JST connectors and pulled them out next to the board, and then I've labeled them. And they have two labels, and the color of the wires is irrelevant. That really doesn't mean much, though I did color the 5-volt and ground lines red and black. And then my nomenclature I use is basically the pin number on the microcontroller that it connects to, in this case D10. And then on the opposite end would be the pin on the component that that wire connects to, in this case the clock pin of the PS2. And then these red labels correspond to the labels on the board for the JST connectors, just so you don't get lost. So you can see here in this case, it's showing these 5 connectors, which is these 5 connectors right here. And then this group here you can see is these 3. This one's the MPU unit. Then I have a bank of JSTs here that I pulled out. So that's basically how I did this wiring diagram. Okay, so first of all, I have both versions of my board here because I still have not finished soldering up the new version. So I have here the original version, 5.1, just sitting on top of that one. And the reason being, the only difference between these two boards is this power section right here. And the 2 little dip switches that I showed in my previous video, but that's irrelevant to this video. Okay, so let's start at power. Okay, your battery power comes in and it goes straight into the high voltage or high current voltage regulator, which is set to drop that voltage down to 6.8 volts, which is what our motors want. Okay, so from the output of this regulator, we're going to go straight into our first terminal on the new board. Or in the case of previous to the board, I just had this little terminal block wired up. So these 2 wires came straight from there. Because that source voltage then gets split to 3 different components. One being the 5-volt regulator underneath Nova. And that's what these 2 blocks are for. So one is 3 positive lines and one is 3 negative lines. So for the 3 places this power splits out to. So one of those places is, again, to the 5-volt regulator, which drops it down to 5 volts, which then comes up right here into the main board, into that terminal block. The second component, it goes out straight to the PWM controller, so that gets the full 6.8 volts that this is set to. And then the third just goes out to the small little voltmeter we have on Nova's rear, just a little display, so it can display 6.8 volts. So what we have here is this terminal right here is the incoming power from the voltage regulator, which is going to sit in this cutout of the PCB right here. And then if we look at my diagram, that would be this terminal right here. So you can see 6.8 volt buck. This is incoming. So it comes from that device's ground and voltage out. And then essentially in the PCB, this is wired to these 2 terminals so that we can share the 6.8 line to these 3 devices. The motors, the PWM controller and its switch on the back of Nova, the 5-volt buck converter underneath Nova, and the voltmeter on the back of Nova. Now, you guys may have put your voltmeters and switches and such elsewhere, but you'll know what I'm referring to. Okay, so that's pretty much the power supply and how it splits and where it goes, etc. Then the voltage regulator will tap off of the incoming battery power to this, and it will tap off and come to this power, this terminal as well, which then goes through the voltage divider into the teensy to monitor the voltage of the battery. All right, so that's the powertrain basically. Here we have the voltage regulator incoming power from the battery. So the battery comes in, ground and VIN, and that's all there is to that. From there, the PCB handles the rest. It goes through the resistors, the voltage regulator, to the teensy. Okay, next let's talk about some JST connectors. So the only ones on the body itself, not head, not the top, would be first the PWM controller, which plugs in right here, which you'll obviously see the markings on the board, so I won't go into that so much. But now I'll show this on the wiring diagram so that you'll understand. This is one of the easiest ones because it's pretty much one for one. These wires go straight to the PWM board in the same configuration. The PWM controller is pretty much 1-to-1 pin, as I explained. So you'll notice on your PWM control board, you have a 5-pin, actually, my apologies, there's 6 pins, I believe. 1 pin we are not using. That would be if you were using LEDs or low voltage motors. You can actually power them through a pin, that 6th pin, which we are not using, which I'm sure you all are already aware of. We feed that direct 6.8 power. So yes, these are 1-to-1 with this JST connector, nothing fancy about it. The only thing you always should pay attention to whenever there's a power line to make sure that you have the orientation correct, obviously. And on the latest board, I did go ahead and put positive signs on the side where that 5-volt line should be. Okay, and then next we have the battery monitor. Well, what used to be the battery monitor. If you're using the old board, you'll still have a wire come in that you'll plug into the JST here. If you're going to use the new version of the board, you will no longer need this because these 2 leads are going to come into this terminal block instead. So this is why I haven't finished up my project yet, because I do have to do a little rewiring to make it all work. So yeah, you may or may not have or need this JST connector for this. And then also, if you're going to use the current sensor, this will also be wired to that, which I'm also not using. As explained, this battery amp JST connector is really optional. Most of you probably will not use it for the battery monitoring. You may just use it for the amperage. However, if you did go ahead and build the DIY board that I originally had built for this, that has both the voltage divider and the current sensor on the one board, then yes, that's designed to have 2 leads coming out of it. And one would be for the battery monitor and one's for the current sensor, which would plug in here. You'd monitor both. If you do not use that DIY board, then you could still connect your current sensor here with its output, and then you can use the onboard voltage divider and battery monitor, voltage monitor here. So therefore, this pin, JST connector, I left grayed out because I personally am not using it, because I'm not using the current sensor anymore. And obviously I'm using my onboard voltage divider. Okay, this I already discussed. This comes from the 5-volt regulator underneath, directly into the main board power. And then the only other thing, part of the body, is the MP3 player. And that has its own JST with positive, negative, and then its 2 input pins. And that plugs in right here. So I'll also show this now in the wiring diagram. So the MP3 player, its JST connector is right here. And we have 5-volt ground, TX, RX. And those coincide with D0 and D1 on the teensy. And those are actually software serial, so there's no need to worry about, let's do that section over again. So next is the MP3 JST connector, which is right here. And it is 5-volt ground, TX and RX, and those coincide with 5-volt ground, D0 and D1 on the teensy. And guys, this is a good example to remember that I am not a professional. And here is something that may actually throw you off. If you look at the board, I have the positive line on this side of the JST connector. So this little part of the symbol indicates the side of the JST connector that has the two little breakout clip pieces. So try to pay attention to your orientation and don't trust the orientation. I did the wiring here because in this particular case, it's ass backwards. It's not wrong, I just drew it backwards. I should have put 5-volt ground, D0, D1. So yeah, I know none of it is wrong, but like I said, in this case, the orientation seems off. There are ways of checking it. You could easily trace these wires right here and see that they go to D0 and D1 on the teensy, which will tell you the orientation. But I know these positive markings that I put on the board are correct, and I know these wiring order is correct. Again, in the case of this one, the orientation is flip-flopped. So please be very, very conscious of that. I will go in and adjust this wiring diagram now that I caught that, but that problem may exist elsewhere and I won't catch it. So please double check your own work. Okay, so that's all for the body wiring. Now, this harness here, let's call it, comes from Nova's head. So in her head is the RGBs, the ultrasonic sensors, and the OLED. Okay? Now, the OLED, I actually have two JST connectors. You can ask me why I did that if you want to, but I may not have an answer for you because I think I forgot why. I think it had something to do with me swapping out the SPI display for the other one that we were using. So anyhow, you have two connectors for the SPI display, which both go right here. So I'll show those on the wiring diagram. So up here we have the bank of JST connectors for the wiring harness from Nova's head. And as explained, the SPI OLED has two JST connectors, which you can see here and here. And those relate to the pins on the left, in the case here, clock and MOSI. And then here, cable select, reset, and yeah, help me out on that one, guys. DC, data something maybe. And then we have the RGB JST, which goes right here, and I'll show that on the wiring diagram. And here is the RGB, which carries 5-volt ground, and then its single data pin. And then finally, we have the ultrasonic sensors, and I'll show that on the wiring diagram. And here is the fourth harness for the ultrasonic sensors. And there are two, left and right, and each has two pins, trigger, and echo. So you can see that here. Now, just all you have to do, you can do it in the same exact order, and that will coincide with these correct pins, and you should be good. Most of this stuff, guys, you can always refer to the software. If you scroll down to the section where I set up the ultrasonic sensors, you will see the 4 pins listed there along with their correlation, trigger, echo, left, right. So you can always confirm that I'm correct on my diagram and you are correct in your wiring. And I really think you guys should be okay figuring all this out. And something that may look odd to you when you're wiring this up, when you go to connect your ultrasonic sensors, you may say to yourself, hey, wait a minute, Chris, these also have 5-volt and ground pins to each one of them. Why is that not on the JST connector? Well, for those of you who haven't already figured this out, and when you tried wiring it, all of these JST connectors or wiring harnesses are going to the same place, in this case, Nova's head. So there was no need to carry 4 separate 5-volt and ground lines. So in the case of this and her top, her lid, I only carry 1 set. in one of those JST connectors, and then at the head or in the lid, it'll split out to share that with the other 2 or 3 components. So in this case here, I'm passing 5 volt and ground with the RGB, and then in Nova's head, the display and the ultrasonic sensors tap off of that same 5 volt ground line. So that's kept our connectors and connections to a minimum, as well as wires to a minimum, by sharing those lines. It only happens twice, here and in the lid connectors. And quick discussion. Although I might have just showed you this on the wiring diagram, it's worth repeating. In a case like this, don't get confused that your OLED or your ultrasonic sensors don't have power leads. It would make no sense to pass 5 volt lines and ground with each one of those when they're all going to the same place. Therefore, the RGB carries the 5 volt and the ground, which then the ultrasonic sensors and the OLED tap off within the head. So you'll see that I do that a lot. I don't double up on the passing power lines along a wiring harness. I just use one at the board, and then it gets split up at its destination. You'll see the same thing for the cover now, which I'll show right now. So here is the cover wiring harness. Okay, again, you'll see this here is power, and you can see I have power coming into the board, and then this little harness here, I have it unplugged at the moment, plugs in underneath there, which is just 5 volt and ground, and it feeds everything. It feeds the 3 PIR sensors, and it feeds the PS2 remote. Okay, which you can see here. That's why the PS2 remote has 2 connectors. It's power, and then it's 4 data pins. Now I know I used red and black. I've explained that in previous videos, so don't call me out on that. Let me show this all to you on the wiring diagram, and then we'll go over it here physically all at once. Okay, so now we'll go over the hood wiring as the last piece of the wiring diagram. So as just explained, I only pass the power in on one harness, one JST of the complete harness. So in this case, it goes in with the switch panel. So that has 5 volt and ground, and then it also has the analog pin for the RGB dimmer, the potentiometer, and then a digital pin for the OLED power, which both go to the nano. Okay, and then if we zoom out and then scroll down here and zoom into here, we have the PIR sensors, right, left, and front. And notice no power, just one data pin to each one of them, because it's going to get its power from the switch panel. And then the PS2 remote, clock, select, command, and data. Again, no power because it gets the power from the switch panel. And then lastly is the on and off switch, which refers to this JST connector right here. And that doesn't require power. That's just one basic loop going and coming back to the switch, to the reset pin. Well, let me rephrase that, to the on-off pin on the Teensy. As I explained in previous videos, unfortunately, the Teensy does not have a reset pin. You can only shut it off and then turn it back on. So I could do that in software, which is convenient. But reset we had on the Mega, so that kind of morphed into an on and off rather than a reset. So that's the wiring diagram, guys. I will finish up showing you the physical wiring that I've done, and yeah, best of luck to you all. Again, hopefully this diagram suits you. I will fix this one little flip-flop error that we found. Everything else seems good to me. Okay, so yes, here's the PS2. It's 4 pins, and then it gets its power from the 2 power pins that come along in with this harness. Okay, and then we have just a 2-wire power / on/off / reset button. And then this is for the volume control. And then this one is the switch panel, I call it, which really just brings power in. And then it's for the 2 controls for the nano to dim the RGBs and to turn on and off the OLED. And yeah, there you have it. And then obviously the 3 PIR sensors. Sorry, that's the third or fourth harness. Okay, so yeah guys, those are all your wiring harnesses. Hopefully this physical view in conjunction with me flipping back and forth to the wiring diagram, which is available on the website and GitHub, etc. to refer to, guys. And I think you should be able to figure the rest out from there, hopefully. But of course, any questions, any comments, any feedback, any errors you see, which hopefully you won't, please let me know. Please share, ask your questions down in the comments below or on our Discord server. Alright guys, good luck to everybody wiring this baby up. I've seen so many of you have her already moving, walking, and responding, and that's so awesome to see. Keep up the great work, guys, and please join the community at NovaSpotMicro.com and upload your photos and videos. Much appreciated. See you all soon.